Hey everybody, I wanted to take a second here and kind of explain the decentralization score a little bit more. I feel like there's a lot of confusion going on around what it's actually trying to measure and what we're trying to display here. So first and foremost, what we're measuring, like there's a lot of, everybody really, this word decentralization is really, really overused, especially in our ecosystem. Everybody has a different definition of decentralization. What we defined as decentralization in this score that we currently have on the website is we are measuring the relative decentralization of an asset in respect to its holder count. So what does that mean, really? Well, I mean, if you go to, for example, Cardano scan here and you just search any token and you look at the top holders, you can see that the top holder of Snake holds 7%, the next top holder holds 2%, and so forth. This happens with a lot of tokens. For example, what we're looking at here is we're looking at each token, each wallet, and their relative balance for the token Hunt. So you can see that the top holder of Hunt holds something like 10 million, the second top holder of Hunt holds something like 5 million, etc. all the way down. Let's see if we can go all the way down. This thing would stop disappearing. There we go. All the way down to the 619th and 16th holder who holds 1/1 millionth of a token. And this is the lowest holder, for example. In reality, they're all the lowest holders because they have the same amount, obviously. Now, let's lay some little groundwork and some foundations about some like laws of observers that we drive all of our work by. First of all, every token must have the exact same calculation applied to them. We do not want to give special cases for special situations when a token has a liquidity pool or a burn pool. This is not what we're looking for because ultimately that will allow for an input of subjective opinions, right? I think it's okay if a liquidity pool is X size, or I think it's okay if there's a burn pool. We don't want to introduce any sort of subjective reasoning. So all tokens have to have the exact same calculation applied to them, and all information we use for our scores must be on chain. So these are the two, I don't know, like pedestals that we build this risk score around, really. So let's go back a little bit to the decentralization score now that we've understood what exactly and how exactly we're going at this. So we talked a little bit about the snake decentralization, or the snake holder count, right? The first one has 7%. We looked over at Hunt as well, and we saw the first holder is something like 10 million. Well, easier than looking at tables that are super, super confusing, it's always better just to go to a graph. Um, so if we take, for example, Hunt here, and we want to graph it, what do we end up getting? We end up getting a graph that looks like this, right? And now what is this graph explaining here, and what are we looking at this with this graph? Let me turn that off. What we see here is on the x-axis, we have the holder rank, right? So we remember we saw that the biggest holder of Hunt holds something like 10 million of the token, and he's on x equals 1. He's the first highest holder, so he's the first on here on the x-axis, and he also is the largest. The second largest, and so forth, all the way down to those really, really small 1/1,000,000th of a token type of people we see. Now this L-shaped line has a very particular name and understanding in physics and in mathematics in general. This type of distribution, this distribution of the token across all of its holders, is called a power law. Now, what is a power law? If we go to good old Wikipedia, we can see this one's a bit nicer looking, right? But it's the same general idea, right? We have this very long tail going to the left, to the right, and a very long tail going basically into infinity on top here. These types of power laws or these types of distributions pop up everywhere in real world. If we scroll down here, we can see some examples, right? Artificial intelligence, the neural scaling law, astronomy, biology, chemistry, climate science, general science, economics. We have here, for example, the population sizes of cities, or the income distribution for a market economy. In finance, we have the returns for high-risk venture capital investments, large price changes and volatility. Tons and tons and tons of things in our real world follow the power law. And as it turns out, so does holder count across almost all tokens. So let's take a look at the power law a little bit more, right? This is the power law. If we were to take the Hunt example here, and if I was just to zoom it in, just to make it look a little bit nicer, so let's just maybe take like the top, I don't know, 500 holders. This line here very much resembles this line here. Now this line and the power law is a mathematical equation. You can see here y equals x to the power of minus some variable. Now this variable defines the curvature of this curve. If I move this variable around a little bit, you can see the curve changes with the way I change it. So if I bring a all the way down to 0, people familiar with mathematics, x to the power of negative 0 is just x to the power of 0, and anything to the power of 0 also ultimately becomes 1. This is why we have 1. Now, what does this mean when it comes to decentralization, for example? Well, a token that is heavily centralized would have all of their money in one wallet. So for example, when we were looking at the holders rank earlier on the earlier hunt graph, we can see here again, remember, I just want to remind everybody that the first X data point here constitutes the highest ranked holder, so the biggest holder. This X equals 2 equals the second ranked holder. And if we just, I don't know, let's just look at this one, for example. The 63rd holder has something like 222,000 hunt. So the x-axis, once again, is the ranked position of the people holding, and then the y is the balance they own. So again, this line very much resembles a power law. Very much resembles a power law. Now, when we're talking about power laws, in general, what we're looking for distribute in a perfectly decentralized world, right? Everybody would have the same amount of money, right? The first holder here, you can see that he has 1 token. The second here, you can see that he has 1 token. The third person here also has 1 token, and so forth until infinity. Now, let's look at some tokens. Before we look on tokens on chain, I apologize. Let's just play this out. So yeah, so for example, we have this line here that shows that every single person, this line shows us that every single person in this imaginary coin would have the exact same amount of tokens across all the holders. And if we were to change the coefficient here all the way to super centralized, we now all of a sudden see that a large majority of the token, or the area under the curve, or the amount of balance, goes to the first couple holders, and then after that it basically goes down to 0, just like we see here. Now what's cool, and what's really cool about mathematics in general, is we can take this very complex relationship of very decentralized to very centralized, and if we plot it in a very, oops, let me redo that. Whoa, I'm going crazy here. And if we plot it in a very specific way, which is called a log plot. So instead of taking just the number 1, 2, 3, 4, 5, 6, 7, 8, 9 on the x and the y-axis, we take the logarithmic value of both of these. This line, or this curve that we had before, all of a sudden becomes a straight line. And what happens when we start varying that line? The line starts to spin. So we go from very decentralized to very centralized. Okay, so this is all whatever, who cares, right? In mathematics, if we can get a linear relationship like this, it's a very easy thing to calculate and a very easy thing to understand mathematically. Now, let's look at some tokens on chain real quick and see their distributions. So here, no, we'll take that one for later. Here we have, for example, Indy. The first graph here, we have the holder count. Once again, I'll just zoom into the corner here so it's a little bit more interesting because you don't see anything. You can see we have, once again, that curvature. Let's zoom in just a little bit more. We have that curvature we were seeing from before. Let me try that one more time. Just make it a little bit nicer. Square. Fair enough. Good enough. We can see we have that curve we were looking at over here. Again, if we bring this back to the regular plot, we have a curve that very much resembles this, of some varying A of some sort. This is for Indy. Let's look at Hunt, for example, because we were already looking at it. We already kind of looked at it, but let's just do it again for the fun of it. So let's zoom into the corner here. We can see once again a power law. If we look at another token, for example, World Mobile token, we can again go into this tiny little corner here and see once again a power law. Now, when we plot these power laws on a log plot, I remind everybody that we take this curve, and if we plot it on a log plot, we get a linear relationship, and the slope of this line tells us something about the decentralization. If the slope is 0, like this, it means the token is 100% decentralized. Every single person in this token ecosystem has the same amount of tokens. If a token is very centralized, it means one person holds a significant amount of the tokens in comparison to everyone else in that token. Okay, I hope that made a little bit of sense. Now let's look at some more data. Let's see, I wanted to say something else. I have a notepad here. So what are some of the issues with this score, right? This holder count is an important metric to look at when looking at decentralization. But in theory, if you have six holders who have the exact same amount each of them, that will be more decentralized than a token with 600,000 holders and chaos going on and things like this, right? This is a constraint of the risks of this decentralization score. And really, the constraint really means you have to look at the decentralization score relative to the amount of holders, right? What you're looking for in general is you're looking for the highest decentralization possible with the most amount of holders you can possibly have. If we go to our application, I don't want to remove that because yeah, actually let's go back from here, and we can look at the see we have these risk ratings here, and we can open up the advanced filters, scroll down to decentralization by rank. I have already linked. We can then take it and drag it over here just for the ease of it to be right next to the number of wallets. And then if we sort by it, we can see that, let's sort by the other way. Yeah, we can see that the number one decentralized token is this token I've never heard of in my entire life with 42 wallets, right? This, even though it has the most decentralization, let's look at this token on CoinMarketCap. Yeah, so here's that same token, GNMPTU up, which has a total supply of 42 and also has a holder count of 42 if I'm not mistaken. But you can see that each one of their balances, the first two have 2 tokens and everyone else has exactly 1 token. If we go back to the curve we were talking about, I want to remind everybody that what we see there would be a curve that everyone is very, very similar, maybe just like even less than this, even less, like that, where we have those 2 wallets who have just a slight bit more, and everybody else has everyone else has the exact same balance into infinity for those 40 wallets. Only 40, right? If we go back to our website, so really what you want to do with this decentralization score is you want to find the highest decentralization possible in relation to the amount of wallets. I would prefer a 5th highest decentralization with 325 wallets than I would with a 3rd with 3 wallets, for example. If we keep going down here, we kind of want to look for here. CDOG, for example, has 15,000. A very, very old meme coin. Makes sense. Same with Bank, a very, very old meme coin. If we keep going down, we can see here, Copy and Hunt have very large holder amounts, and they're very low on the decentralized, or they're very close to being number 1 on the decentralization score. This is what's desirable. You want to have a lot of holders with a relatively high decentralization score. Because once again, I want to remind everybody, we measure every token with the same exact metrics. And this is by design and this is by intention. Yes, there's lots to go, right? And there's still ways we need to weight this score, for example, right? Obviously, we don't want to be calling a token with only 42 wallets the most decentralized, but we also don't want to be calling just the highest wallet count the most decentralized either, because, for example, with Hosky, which has the highest decentralization amount, 50% is in one wallet, and then, well, let's actually go to the website as well, and let's go see Hosky's decentralization. Hosky, you can see they're 74th in decentralization, but they have a ton of holders, and if we go to their holders by sea creatures, we can see that 50% is in one wallet, another 22% is in 3 wallets, or 17% or so is in 1 wallet. So about 67% is in 2 wallets, right? This goes back to our decentralization curve that we're talking about here, where a mass majority of the tokens is in 2 to 3 wallets, and everyone else shares the rest of what there is there. This creates, once again, a power law, which we can then measure the slope by and understand who's more decentralized than others in relation to their holder count. Now, let's talk a little bit about weighting, right? Because I was just referring to, we want tokens with a lot of holders and also a really good decentralization rank. That's what we're looking for here. If we look at the top decentralization, we can see that GNMTP with only 42 wallets is the top of decentralization because every single one of their 42 holders holds 1 token, which is, in theory, the most decentralized because everyone holds the same amount, even though it's a very little amount with a very little amount of holders. So we definitely need some way to weight this decentralization score in relation to the wallets. Problem is that when you look at the holders, the amount of holders per token, so we were looking earlier at wallets was the x-axis and their balance was the y-axis. Now we're looking at tokens being the x-axis and the y-axis being the amount of holders they have. So number one here would be, for example, Hosky with their 90,000. And the next one is SundaeSwap, if I'm not mistaken, and so forth. SundaeSwap, the second rank, and then the very least rank. The token we're just looking at in the decentralization is somewhere much, much over towards the end of this tail. This is, once again, if you can see this line should be, you should kind of recognize this line already. This is another power law. Now, what's the problem with power laws? They have no averages. We can't just average and say, okay, the average holder count is this much, which means if there's no average, we basically can't normalize by it either. Because if we were to normalize it and try to equate the amount of holders as some sort of weight, Hosky and Sunday, even if they have the worst decentralization, just because of that weight would be so much larger than the weights of everyone else, it would wash them out and Hosky and Toki would win, which is not what we're looking for. Hosky and Sunday, Hosky and Toki. So in review and just in brief, what we're looking at here is we're looking at the relative decentralization of an asset in respect to its holders. If all the holders hold the same amount of tokens, that is decentralized. If the holders don't hold, if one holder holds a massive amount of supply, that's more and more centralized, right? This one theoretical wallet or these two theoretical wallets have like unimaginable power over the market. So what we're trying to do is we're trying to get tokens to be, if you think about like the minting of a token, right? All at the minting instance, all the tokens are in one wallet, and the goal of tokens in these ecosystems should be to become as decentralized as possible. So as we move on with life, the token, more and more people get it, and less is held with the larger parties, all the way until we get to this one point where everybody's even.